19.6. The transition state and product formation. How does the enzyme promote a faster chemical reaction? As the substrate interacts with the enzyme, its shape changes, and this new shape is going to be less energetically stable. So this is what we refer to as the transition state. The transition state has the features of both the substrate and the product, and then it falls apart to yield the product, which dissociates from the enzyme. Notice that in all of these reactions shown down here at the bottom, that the enzyme is completely unchanged throughout the entire sequence. What kind of transition state changes could occur in the substrate that would make the reaction proceed more rapidly? The enzyme might put a stress on a bond and thereby promote bond breakage, as in the example of sucrase shown here. The enzyme catalyzes the hydrolysis of sucrose into glucose and fructose. The formation of the enzyme substrate complex, shown here, results in a change in the shape of the enzyme, and this in turn may stretch or distort the bond between the glucose and the fructose. This bond shown here, which will weaken the bond and allow it to be broken much more easily than in the absence of the enzyme. An enzyme can also facilitate a reaction by bringing two reactants closer together with each other and in the proper orientation for the reaction to occur. If we look at the reaction between glucose and fructose to produce sucrose, we can see that each of the sugars has 5 hydroxyl groups that could undergo condensation to produce a disaccharide. By random molecular collision, there is a 1 in 25 chance that the two molecules will collide in the proper orientation to produce sucrose. The probability is actually much less because most molecular collisions won't have enough energy to overcome the energy of activation anyway. The enzyme can bring the two molecules close together and in the correct alignment, forming the transition state and greatly speeding up the reaction. The active site of an enzyme may modify the pH of the microenvironment surrounding the substrate. For instance, it may serve as a donor or an acceptor of H+. This would cause a change in the pH in the vicinity of the substrate without disturbing the normal pH elsewhere in the cell.